present, 21 students are present. Okay. Skip list, why we require a skip list means, I think you people already studied in the first internals about how we are going to do a linear search. Okay. By using a formula based representation also you are doing, as well as the link based representation also you are going to do it. When you want to insert an element at the position of 15 means, so what you are going to do means, which all the element is present are, let us consider as there is a 30 elements, 30 students are there in a class. So what I will do means, I will allocate only 30 memory location for 30 students here. So what 30 students will be present in one classroom here. I want to insert another person means, so what I will do means, I want to allocate a new person, new bench will be allocated for the particular students here. So what happened here, I want to insert new element at the position of 15. At the 15th position, I want to insert a new element, new student I want to insert. So what I will do means, 30 students are already occupied in the classroom. I will shift the 30 students to the new bench. And then I will keep on shifting because I want to insert the new student at the 15th location. So what I will do means, I will keep on shifting the student from the 30th to the 15 students, and then I will allocate the free space for the 15th, and then I'm going to insert the new person at the 15th position. So what happened here? So in that one, the complexity will be more here, because I need to shift all the from the 15th location. There will be space should be provided, so that I need to shift all the element from the end to the 15th location. I'm shifting all the person, so that 15th at the, I will allocate a new space for the 15th person, and then I'm going to insert an element at that position here. So what happens here, the complexity of the complexity will be very high. So because I am searching from the last element, in which location I want, I'm keep on searching. So in order to avoid that part and all, we are going for the skip list here. Here in this one skip list, what happens here, let us consider as 1 2 3 4 5 6 7 7 elements are there in this list. I will find out the middle point here. The middle point will be the 40 is the middle point here. So once the 40 will be the middle point here, I will keep this as a middle point. If I want to search an element, 77 means whether the 77 is present in the list or not. So what I will do means, I will find out, 40 is the middle point here. 77 is the person I want to find, whether the 77 is in the list or not. So what happens here, this is the left shift and this will be the right here. Now let us consider this is the left side and this is the right side here. So what happened here, 40 is the new 40 is the new person. Sorry, 40 is the middle point here. 75 is the new person. I want to insert whether 77 is the new element. I want to find whether it is there in the list or not. So what happened? 40 is the middle point here. 77, 40 is lesser than that of the 77. So what I will do, I will not search on the left side, because all the elements which are present on the left side is greater than that of the, all the element present on the left side is, that 40 is the middle point here. So all the element present on the left side is lesser than that of the 40. So all the element, because I want to search 77, 77 is greater than the 40 here. So all the element greater than the 40 are stored in the right side here. Now I want to search an element 77 means 77 is should be present on the right side. So I will not search on the left side, I will search on the right side. So what happens here, half of the time will be reduced here, right? I will not search from the left side, I will search from the right side here. 77 is the person I want to find whether it is there in the list or not. So what happens here, so I will search on the right side whether the person will be present in the list or not here. So complexity of the time also will be reduced. So what happens here? Here in this one, you need to aware about, always in the tail node, there will be two pointer will be there. One will be the header pointer, another will be the tailor here. One will be the header, another will be the tailor here. Always the larger number will be stored on the tail element. Now let us consider as 1000 is the largest element. I will store the 1000 element in the tail node here. And then here in the tail, only the data will be stored in the tail. You remember, in the tail, only the data will be stored in the tail here. That is a 1000 is the element which will be stored in the tail here. And in the header, there will be pointers will be there here. Pointer which is pointing to the pointer will be there in the header here. And then here in the tailor, there will be large number of element which there is a largest element. That is the 1000 is the largest element that will be stored in the tail here. So what happens here? Here first we are doing as a allocating the middle point here. There is a 40 here. Whichever the element we want to search, whether it is on the 40 is lesser than that of the particular element means I will search on the left side. If the any element I want to search means that is greater than that of the 40 means I will search on the right side here. So the time also will be reduced here. How many levels should be there here? So that 40 is there, no? 40 in how many? Let us consider there is a 7 elements are there. Here for this 7 elements, how many levels should be there here? That is a level 0, level 1 and level 2. Okay. For these 7 elements, how many levels should be there here? Level 0, level 1 and level 2. How many levels are there? 3 levels should be there for a 7 elements. So now let us consider as if there are 30 students are there in a classroom, is how many levels should be there for a 30 students here? I don't know. That all depend upon the formula, cutoff formula. Depending upon the formula here, we are going to decide the levels here. Now suppose for this there is a 7 students are there in a classroom. Suppose there are 7 students are there in a classroom is I have a levels called as, suppose I have a levels, my levels might be 7 levels are there for a 7 students, but I don't require 7 levels for the 7 students here. I required for a 7 elements, I required only the 3 levels I required. For a 7 students, I required only 3 levels. But how many levels I have? 7 levels I have. So what I will do is I will reduce the level. So I will fix the levels, how many levels I require, that many levels I will assign only for the 7 students. So what happens here? Here in this one, this is the 40 is the middle point here. The 40 will be present on the level 2 as well as the level 1 as well as the level 0. And then here 24 is the second pointer here. 7 that is a 24 is the another element. That 24 will be present only on the level 1 here, but it is present in the level 0 also. But 24 element is not present on the level 2 here. And the 20 element is present only on the level 0. It is not present on the level 1 as well as the level 2 also. That you should have to aware, because here 40 is the element which will be present on the level 0, level 1 as well as the level 2 also. Here 24 is the element which is present only on the level 1 as well as the level 0 also. 20 is the element which is present only on the level 0, not on the level 1 here. So when you decide that one, in the level 0 here, all the elements are linked here. In the level 0, all the elements are linked here. See, in the level 0, 20 is linked with the 24, 24 will be linked with 30, and then 30 will be linked with 40, and 40 will be linked with 60, 60 will be linked with 75, 75 will be linked with 80 here. In the level 0, all the elements are linked. And in the level 1, only the few half of the element which is present on the level 0 are linked in the level 1. Half of the element, that is 1, 2, 3, 4, 5, 6, 7. 7 elements are linked in level 0. All the 7 elements are linked in the level 0. But when you come to the level 1, half of the element which will be linked in the level 1, that is a 1, 2, 3. 3 elements will be linked in the level 1. And when you come for the level 2, that is it, how many elements are linked in the level 2 here? Only one element is linked in the level 2 here. So the probability of occurrence of an element in the level 0 is 1, because all the elements are linked. The probability of occurrence of an element in the level 0 is 1 because all the elements are linked. The probability of occurrence of the level 1 is 0.5 because half of the element which is present on the level 0, only half of the elements will be linked on the level 1. That's a 0.5. The probability of occurrence of elements in the level 1 is 0.5. And in the level 2 here, the probability of occurrence of an element in the level 2 is 0.25. Because when you compare with the level 0, all the elements are linked. When you compare with the level 1, only 0.5% of an element is linked. And when you come to the level 2 here, only 0.25% of an element is linked here. So this one you should have to aware here. So here in this one, if you see here in this figure, see here, 40 is the element which is linked on the level 2 as well as level 1 as well as the level 0 also. So where this pointer will be in the header, we have a pointer node that will be pointing to the 40th element. And this again, this here also there is a pointer will be there that is linked to the tail node. And then here in the second level, this is in the header point. In the header also we have a 3 nodes. One will be the header have a 3 nodes. One will be the level 1, level 2 as well as the level 1. But in the Taylor, see the Taylor, there is a largest element will be stored in the Taylor. This you should have to aware. In the header, there is a 3. In the header, we have a 3 nodes. One will be level 2, level 1 as well as the level 0. But in the Taylor, there will be only the largest element will be stored in the Taylor here. Now suppose in the figure C, here in this one figure C, this is one of the diagram. I want to insert a 77 node. So if I want to insert a 77 element means, first I need to search whether the duplicate element will be present in the list or not. If the duplicate element will be present in the list means, then I will initialize a there is a bad initialization here. Okay, that we need to search here. And another thing is 77 is the element which I want to insert in the list means which all the levels it should be present also we need to check. In which all the levels that 77 should be linked here. That also we should have to aware that. So now here in this diagram here, 40 is the middle point here. Now I want to insert a 77 here. So what I will do is, which location I want to insert an element here. So now I will find this, but here 40 is the middle element. I want to insert will be the 77 means. First, what I will do is the point I will just 40 is the lesser than that of the 77. Then I will decrement the level here, and then again the level will be level 2. I will come to the level 1 here. From the level 1 again there is a 77 is the 75 is present over on the level 2 here. 77 is the element which is present on the level 1. Now I want to insert 77. 77 5 is an element which is present on the level 1. Now I want to insert 77. So here, this is one point I got it. Now I will decrement the level here. Now I will come to the level 0 here. When I decrement the level here, so I will come to the level 0. My pointer is pointing to the 75 node here. After that, I will allocate I want to insert a 77 after the 75 here. So what I will do is, y is equal to new node, that is a 77 I want to insert after the 75. So what I will do, 77 node have one address. Let us consider that address will be 100. That address will be stored on the 77th link here. And this new node, y is equal to new node, that here the 75 here, saying the 75 is the node here. In the 77 node, the address part is the new element address part will be stored over on the 75 link here. So that what happens, after 77 will be linked to the 75. And then here 80th address will be stored on the 77th element. So that 77 will be linked to the 80th here. So this is how it will be linked here. And then after that, what happens here? Where I need to find, because see here, 77, is the element which is already linked here, but the 77 link should be present on the level 2 also, level 1 also. But it is not present on the level 2, but 77 will be present on the level 1 as well as in the level 0 here. So first what we need to have here is which all the point that 77 should be located here. The 77, where the pointer will be the after the 75, that should be linked to the 77, as well as on the 0th location also the element will be linked to the 77 here. So there will be two pointers should be present on the level 0 as well as in the level 1 here. That will be linked. That 77 is the element which will be present in the level 0 also as well as in the level 1 also. This is how we are going to insert an element. Now let us consider as if I want to delete an element means 30, I want to delete an element means once the element will, how you are going to delete an element 30 means the 40th address, that's a 24th, 40th address will be linked to the 24th. Then again the 30 element will be deleted here. That is a 40th address will be linked to the 24th. Then after that we are going to delete the 30th element. After once the element will be linked to the 30th element, we need to check whether the 30th element is present in the level 1 as well as in the level 2, but it is not present in the level 1 as well as the level 2. So there is no need to bother. Now if I want to delete an 24 means that is a 30th address will be pointing to the 20th address, 20th location. So the 20th will be linked to the 30th. So again the 24th element will be deleted here. But the 24th element will be present in the level 1 also. So again this link also will be erased. So what happens here? This address will be directly connected to the 40th. 40th address will be directly linked to this level 1. Then so that 24th element will be deleted here. So the 24th level will be present in the level, 24th element will be present in the level 0 as well as in the level 1 also. This is the theory concept of the linked list here. So now we will go, sorry, this is the theory concept of the skip list. Now we will go through the theory part, how it is working here. You got it right, concepts?
Yes, ma'am.
Varsha?
Yes, ma'am.
Got it, the concepts of the skip list?
Yes, ma'am.
Okay,
Yes.
now can anyone explain me how it is working, the skip list, so that we can go through the what all the things you have understood from the skip list here? Yes.